In this video, we're going over the memorization approach of House Robber 2. So let's go over the thought process. So the recursive approach is inefficient due to overlapping recursive calls. We can't avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are trying to find the maximum amount of money at the current index I. This means we can cache I with money. Now let's go over the pseudocode. So we'll still validate the input parameters. If the input array is empty, we can just return 0 because there are no houses to rob. If nums.length is equal to 1, there's only one house, so we just rob the first house. Now we're still going to create our method to find the maximum amount of money we can rob. But what parameters do we need? We need the current index, the last index we can rob. This is because if we rob the first house, we are not allowed to rob the last house. And if we rob the first house, and if we start robbing from the second house, we can rob the last house. And then we will also need to pass in our memo, which is our cache. Now, what is the base case? If I is greater than n, this means there are no more houses to rob, so there are no more money left, so we can just return 0. And also, if memo I is not equal to -1, we'll go over later why is it not -1. If it's not equal to -1, this means we have already cached a result here, so we have already found the result for the current index I, so we can return memo I. Then, in each of the recursive call, we can recursively find the amount of money if we rob the current house. If we rob the current house, we have to skip the next house. This means we have to jump to I plus 2. And then we're going to recursively find the amount of money M2 if we skip the current house. If we skip the current house, we can just move on to the next index, which is at I plus 1. Now, before we return the results, we want to put the results at memo I. Then we want to return the cache results. And this is robbing the maximum amount of money if we rob the current house. This means we have to increment it by the amount of money that we gain at the current house, and also the maximum amount of money if we skip the current house. And they want to return the larger value between the two values. Now we want to create an array memo to cache previously calculated results. Now I want to fill memo with -1. This is to prevent the side case where we are not allowed to get any money from the houses. Now we're going to recursively find the maximum amount of money M1 if we start at index 0. If we start from index 0, we are not allowed to rob the last house. And the last house is located at nums.length -1. So our last house we can rob is at nums.length -2. And we also need to pass in the memo. Then we want to, before we perform the recursive call for our second method, we want to fill memo with -1 again. This is just to prevent us from using the results of the previous recursive call. Because we are passing the memo to this recursive call, we do not want the results to influence this recursive call. Now we're going to recursively find the amount of money M2 if we start at index 1. If we start at index 1, we are allowed to rob the last house. And then want to return the maximum amount of money between robbing from the first index and robbing from the second index. Now what's the time complexity? Time and space complexity. So we get O of 2n plus O of 2n, where n is the length of the input rate. This is, we fill memo of -1 twice, and then we have made 2 recursive calls. So there's a total of n possible states with I. And our space complexity, we get O of n plus O of n. This is for the recursive call stack memory. and also our Memo. Now let's go over the code. So we'll first validate the input parameters. If the input array is empty, we can return 0. If there's only one house, we can return the maximum amount of money or the amount of money at the first house. Now we want to create our cache, Memo, to cache previously calculated results, and then want to fill Memo with -1 to prevent the side case where there are no money to rob. And then we want to find the amount of money, M1, if we start from the first index, or at index 0, passing in our Memo. If we rob starting from the first house, we are not allowed to rob the last house. So the last house we can rob is that nums.length -2. And then want to fill Memo with -1 again. And then want to find the maximum amount of money, M2, if we rob starting from the second house. They want to return the maximum amount of money between the two initial choices. And then we need to update our recursive method to use our Memo. So the base case is if I is greater than n, this means we have passed the last house that we can rob. So there are no more houses to rob. So we return 0. If Memo I is not equal to -1, this means we have already cached the results, or we have already calculated the results for the current index. So we can just return the cache results. Now before we return the result, we want to cache it. And now the first choice is if we rob the current house. If we rob the current house, we want to jump to index I+2. Or we want to skip the current house. If we skip the current house, we just move on to index I+1. Let me know if any questions in the comment section below.